Hello, hello. Please tell me once if my voice is clear to all of you so that we can move ahead. Okay, voice is clear. Fine. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good in your studies. Okay, so if I will be talking about our current ongoing topic, we have nearly completed most of the portions of optics, ray optics specifically I am talking, or geometrical optics. Now we are into the last section, and in the last lecture only we have started about the lens formula, how we derive the lens formula from the spherical surfaces of refraction. So we have derived from there. If you have not watched that video, please go and watch. We have discussed in complete depth about this complete chapter. Okay, complete ray optics we have understood in complete description, so you can follow that playlist also. Okay, so in this lecture what we are going to understand about combination of lens, about magnification of lens, about velocity of object, image, all these things, silvering of lens. This is also what we are going to understand. These things we are going to understand in this lecture. So are you ready? Should we start? Let's begin. Okay, nice. So first thing is transverse magnification. From mirror only you are learning about magnification from that much time. Okay, because what if I will tell you that what is magnification? What is magnification? Magnification was, okay, magnification was what? If my height is, let's suppose 5 meter. Okay, my height is, let's suppose 5 meter. My image is somewhere forming, and the length of my image that is forming there is, let's suppose, 20 meter. So what will we say? How much magnified my image is? So how much I will be saying? 4. How you have calculated? The height of the image divided by the height of the object. That is what about transverse magnification. Now what is transverse? When you keep the object perpendicular to the principal axis, then it is called as transverse. If you are keeping the object parallel to the principal axis, then it is called as longitudinal. Both the cases we are going to understand. So let's understand for transverse firstly. For transverse, what is the formula and how we can derive? See, here is a ray diagram that is drawn here, and let's understand from this same ray diagram how we can get to our formula. See, here is an object. Height of object is given as h0, and this is the distance from the lens, that is u, and here somewhere image is forming and the distance from the lens is given as v. Correct? So if I will ask you, tell me what will be writing. Lens formula is clear, correct? Let's suppose this angle is theta, that means this angle will also be theta. I've told you in the just last minute of the last lecture that if a light ray is passing from the optical center, it will go undeviated at the equal angles. So if this angle is theta, this angle is also theta. Tell me, in this first triangle, what you will be defining? Tan of theta. Tan of theta, you will say, sir, it is equals to h0 divided by u. And in the second triangle, what you will be defining? Tan of theta. Tan of theta, you will be saying, sir, tan of theta is equals to height of image divided by v. Height of image divided by v. So I can write it also as h0 by u is equals to hi divided by v. ये क्या लिख दिया यार? hi divided by v. So what I can write? Hi by ho, height of image divided by height of object. It can be written as, here it will be coming u divided by height of image divided, it will be written as v divided by u. That is what your formula. Height of image divided by height of object is equals to, or magnification can be directly written is equals to v by u. Now let's suppose a particle is moving in this direction with some velocity of object. What will be the velocity of image? That can also be written in the same way. Velocity of image is divided by velocity of object is equals to, simply it can be written as u by v. Same relation I have told you from, for now, as of now we have seen these cases for multiple times. Okay, so I hope that this will be clear to you. Fine. So let's apply this in formula and let's try to understand, because what will be happening, some positive, of course some sign conventions will be coming. So when it will be taken positive, what is the meaning of positive, what is the meaning of negative? Let's understand by the question. Because already we are saying that principal axis is our reference line. Above that anything is calculated in positive, and below that anything is calculated in negative. Correct? So let's see. Find the height of the image and the distance of the image from the lens. You have to calculate what is the height and the distance of image that you will be getting from the lens. See, this is the thing that is given. U is given as 30 and this is given as, height is given as 2 centimeter. Firstly, which direction will be taken as positive? This direction is taken as positive because here is the object, some ray will be going in the positive x direction. So let's firstly calculate v. How will be calculating v? V is equals to uf divided by u plus f. Simply, can I write it? Now tell me, u how much you will be writing? Minus of 30. Focal length will be negative, positive because it is a convex lens. 20 divided by, here it will become how much? Minus of 10. Now this simply get cancelled. Here it will become 60 centimeter. Position of image is how much? Plus of 60 centimeter. That means image, now locate the image, that is the second step. Image is forming on the other side at some distance 60 centimeter. At some distance 60 centimeter. Now if I will be asking you about the height of the image, how I will be saying? Height of image divided by height of object is equals to v by u. So height of image, I can say it is going to be equals to, you will be writing v, that is v how much you will be writing? 60 divided by u. U is how much? 30 into, and this will be written as negative, into height of object. Object is taken as positive, it is 2 centimeter. It is equals to 2 centimeter. How much this will be coming? This will be coming 2 times, and it is 2 into 2, that is minus of 4 centimeter. Height of image will be coming minus of 4 centimeter. That means image will be forming what kind of shape? It will be what you will be saying about the property of this, nature of this image? It will be height of image is equals to 4 centimeter. Now what are the details that you can tell me about the image, this image that you are forming here? You can say, sir, this is what it is. A firstly you can say real, because it was a real object and image is forming on the other side of the lens. That why you can say that it is a real image. First thing. Second thing, what you can say, it is magnified image because the size of the image is greater than the size of object. That means I can say magnified. Now image, the answer is coming height of image in negative. That means it is below the principal axis. That means I can say it is not erect, it is what? Inverted image. So what is the net comment that you will be doing? क्या ये कुल्फी? राजेंद्र सर, क्या चीज की कुल्फी है? स्प्राइट की कुल्फी। ओह माय गॉड, थैंक यू। ठीक है, स्प्राइट की कुल्फी खाते खाते क्लास लेंगे। सी, नाउ कम टू द नेक्स्ट क्वेश्चन। Solve this question. Till then I will enjoy the kulfi of Rajendra sir, made by Rajendra sir. Sorry. अरे क्या है यार? See what is the question is saying? Find the height of image and position image from the lens. From the lens you have to calculate what is the height of image and what is the position of image. Should we start calculating? Let's see what is the answer is going to come. See, firstly understand, two incident rays are coming and actually they are appear to converge at a point. That point will be called as object distance. So this is first thing that you will be understanding from here. It is what kind of object? Virtual object. It is what kind of object? Virtual object. And what is the distance? Distance is given as 30 centimeter. So let's firstly calculate the position of image. What you will be writing? UF divided by U plus F. Now tell me what you will be taking as U. See, this is the direction for incident ray. That means this direction will become positive. If this direction is become positive, what you will be taking as U? U you will be taking as plus of 30. Okay. Now what about the focal length? Focal length, what you will be doing? Focal, for calculating, see here direct focal length is not given. That's why you have to use lens maker formula. That is also a headache that you have to face. Ab calculate karo, solve it. Lens maker formula, what is lens maker formula? 1 by f is equals to n of lens. N of lens is how much? 1.5 divided by surrounding, it is given. Surrounding is given 2. That is also one thing. Minus of 1 divided by 1 by r1. R1 you will be taking, it is going in the right side. That means you will be taking plus of 10 minus 1 by R2. R2 is going in the negative direction. That means it will become plus 20. Ab solve karo isko. Check what is the value coming. Here it will be going minus of 0.5 divided by 2 multiplied by, here what you will say, 3 times of 20. 3 times of 20. I hope that the calculation is fine. Now calculate it. How much you will be getting? This will become 1 by 4, 1 by 80. It will become minus of 80 by 3. Minus of 80 by 3. This answer should be coming as, okay. Let's see how much it is coming. Minus of 80 by 3 divided by U, that is 30, minus of 80 by 3. सॉल्व करो कितना आएगा. It will become 10. Here it will make it minus of 800. Here it will become 90. 90 minus 80, that will become 10 by 3. It will get cancelled. That means answer will become minus of 240 centimeter. Now what is that this distance is reflecting? This is the direction, positive direction. That means object image is forming on the other side in negative direction. And what is the distance of the image from here? It is equals to 240 centimeter. First thing that is clear here, correct? Now what you will be doing, image तो find कर लिया. What is the distance of image? अब calculate करो what will be the height of the image, because height of object is given as 2 centimeter. करो calculate. Apply the formula simply. What is the formula? It's good really. तुम लोग भी कभी ट्राई करना. Sprite, what they called? Sprite kulfi. See, let's calculate. खाने नहीं दोगे तुम लोग. You will be saying height of image is equals to v by u. V is how much you have calculated, sir? Sir, it is minus of 240. U how much you have calculated, sir? Sir, it is given as 30. Into height of object is how much, sir? It is 2. Solve करो. It will come as 8. Answer will become minus of 16 centimeter. That means what you can comment about it, image is forming somewhere here. Image is again magnified, and but the image is what? Inverted. Height of image is given as 16 centimeter. Height of image is given as 16 centimeter. Correct? Now see. Now let's come to the ray diagram. Ray diagram, all of you have studied in the basic classes. Okay, I think that now you are sufficient able to make the ray diagram, because I've told you about the main rays also that are present there. Tell me what you'll be saying about this case. When object is kept at infinity, what will be happening? Rays will be coming parallel, converging at the focus. So what is the position of image? Focus. And what is the size? Point size. Correct? Real object and point size. And we also this is the what you can say about this complete image. Second thing, let's suppose object is kept beyond 2f, beyond the center of curvature. Image will be forming where? Between C and F. Between C and F. This is C, center of curvature, and this is F. And what kind of image will be forming? One ray parallel, one ray directly pass कर दो, you will be getting your image. अगर अच्छे से drawing कर रहे हो तो you will be getting your proper image between C and F. Okay, if you are drawing the correct ray diagram, you can say what kind of image you are getting: real object, real image, inverted image, diminished image. These three things you can comment here. Now next, when you put the object at 2f, image is also forming at 2f. This is very obvious, but this time real object, real image, because this is forming on the other side. That you can say it is inverted image. You can say same size. All these things you can say. Let's suppose you are moving this object more closer to the lens. What will happen? Now this image will be going away from here. When you have brought this object between 2 and f, now it is forming the image beyond that. And what about the sizes? This time you will be say again it is inverted, but this time it is the image is enlarged. Image is enlarged. Again real image, no problem. Now you have brought the image between focal length and pole. Then it forms a virtual image. One ray you pass from the pole, that is go undeviated. Second ray you try to take parallel, and it will be passing from the focus. And but this side it is not never going to converge, and it will appear to converge at the same side of the object. That's why we call this is the only condition where you will be having virtual image. Where you will be having virtual image. Correct. Next one. When rays are coming, and it is first time, it is the only case of virtual object. See, it is appear to converge at a single point. Okay, so this point will be behaving like a virtual object. For virtual object, it is forming on, if it is on the same side. For virtual image, it is forming a real image for a virtual object, because rays will be get converged, it will get converged, and it will going to intersect on the same side. So if it is virtual object, it will be forming a real image. Correct. This is all about, you can say. And one, I think, if it is missed, you know that if the object is kept, if object is kept at the focus, then image will be forming at the infinite. Correct now? Very good. Now let's understand this curve. In the last case also we have understood about this curve, what this curve is trying to tell you. Let's see. What is this? See, what is the length formula? Here is a curve that is between 1 by v. कहाँ गया पेन? Where the pen went? See, this is the curve that you define. 1 by v minus 1 by u is equals to what? 1 by f. Take some lighter color. Okay, this is what the length formula. So the relation is between 1 by v and 1 by u. That means I will say 1 by v is at y-axis, y minus, this is what you will say, minus x is equals to what? Some c. This is 1 by c, 1 by f is equal to some intercept. So what I will say, y is equals to some x plus c. That means what I can say about the slope I can directly write that m is equals to 1, and this is some positive intercept that is going to cut it. For if I am talking about a converging lens focal length is always positive. If focal length is positive, this intercept also I can say it is positive. Clear? So what kind of straight line I will having? Very obvious, this kind of straight line I will be having. Let's analyze one segment. First quadrant, u is positive, v is positive. If u is positive, what I will say? Virtual object. Remember the case, let's suppose this kind of some case was there, some rays were coming like this and they will appear to converge at a point, and that point was called as what? Virtual object, and because it was calculated in the positive direction. And due to that, what is happening here? You are having what kind of image? Real image. Just the last case that we have discussed was same. Okay, now other thing that you can say, if u is positive, that means always it is a real image, real object, and v is positive, u is positive, u is negative, that means it is a real object, and v is positive, that means on the other side of the lens it is forming. So I can say real object, real image. Now here see, in the third quadrant, what you can say? Again, check what is the positive. U is negative, that means real object is confirmed, and this 1 by v is also negative, that means it is virtual image. That means for real object, virtual image can also be formed in converging lens. Okay, what is the case that cannot be formed here? See, when u is positive, that means virtual object is there. For virtual object, there cannot be formed any virtual image. For virtual object, there is not possibility of any virtual image. Okay, this is what you can say about this curve. Now you can derive for same thing, you can understand for the diverging lens also, analyze it. Now this will be a homework. Same way, yeah, because we have did the same kind of thing in that topic also. In mirror also we have analyzed the cases. यार मेरा पेन चला गया. See, now let's suppose there is a longitudinal magnification. I have told you that both of the cases we are going to see. What will be happening with if there is a longitudinal magnification? Nothing. Just differentiate it. Okay, differentiate it. What will be happening? Here you will be differentiating 1 by v. 1 by v differentiation is going to give you 1 by v square into dv. Now here again differentiate 1 by u with respect to u only. What will be getting? Minus is already, that means it will make it plus du is equals to 0, because focal length is not changing, only changing length is what? V and u. So this will become 0. Here what you can say, du by u square is equals to dv by v square. That means dv by du can be written as v square divided by u square. dv by du can be written as v square divided by u square. What is this dv? Change in length of image. That means I can say this is length of image divided by length of object is equals to v square divided by u square. Can you say, if I will ask you at the place of this, what will be the velocity of image and velocity of object relation? So you'll be saying, sir, it will be exactly same kind of thing. Here I am writing what? Length of image divided by length of object. There you will be saying what? Velocity of image divided by velocity of object is equals to v square by u square. Condition is what? This length of object should be very, very less. This should be negligible as compared to the distance of object. In the spherical cases and rest of the places, we have already seen this approximation. Correct? So let's apply this formula. Apply karo. What is the answer is coming? An object of length 2 mm is placed at a distance of 30 cm from the convex lens. Focal length is given, that is 20 centimeter as shown. Focal length is given. Find the longitudinal length of the image formed. You have to calculate what will be the length of the image that is going to be formed. Calculate it. How much the length of the image is going to be coming. Check what you can do. Firstly, what you'll be doing? Firstly, calculate what is the position of image is coming. Position of image वो तो calculate करने आता है, लेकिन सुको वो तो calculate कर लोगे. After the class, I am going to finish it. It is very yummy. See, पहले calculate करते हैं. Well, position of image. Here, what will be saying? UF divided by U plus F. U. How much will be saying? What is the position of object? Position of object, I will say I will take this direction as positive. That's why I will be taking this in negative direction. That means I will take minus of 30 into focal length. How much focal length I am going to tell? Right. Now focal length I will be writing positive of 20 divided by U minus F. That means in net it is going to be minus of 10. Cancel. And here this minus cancel. Answer will be coming 60 centimeter plus of 60 centimeter. This is equals to B. Fine. One part is done. Now I have to calculate what is the length of image. Length of image I will be saying V square by U square. V square means what? 60 into 60 divided by U square means what? 30 into 30. And negative will be there, but negative square करोगे तो वो तो खत्म हो जाएगा. Multiplied by length of the object. बताओ length of the object कितना लिखोगे? 2 millimeter. ये cancel करो. How much it will become? 4. Multiply करो 8 millimeter. And it is coming, better part, it is coming positive of 8 millimeter. Clear? You have calculated the distance, but only valid when this distance is given as 2 millimeter as compared to 30 centimeter. It is very small value. That's why. Okay. So approximation should be very clear. Now, if you have to calculate the velocity, how you will be doing? Just differentiate it in the same manner. Differentiate how much you will be getting with respect to time. Differentiate it. You will be having here minus of 1 by U square into du by dt. Du by dt will become what? Velocity of object. And same way you differentiate this position of object, position of image, and this differentiation of 1 by f will be eventually becomes 0. You will be getting the same relation that like how you get for magnification. Now these kind of things you have did a lot of times, so I hope that this is now clear to all of you. Okay. Now let's come to power. The very basic formula of power. Power is equals to what? 1 by f. But remember, power is calculated in diopter. That is one thing. Diopter is the standard unit where we calculate. But remember one thing, most of the time that the mistake that students do here is power, when you are writing 1 by f, that f is calculated in meters. Always remember this. Most of the time students I have seen making mistake that they just quickly take that units in centimeter. This is calculated in meters. Okay, so please be careful when you are using this. Power of mirror is defined as minus of 1 by, because always we try to do what? We always try to make the converging things as positive power. So because that what happens, if you will focus properly in convex lens, what is happening? It is a converging lens, and power is defined as what? Power is equal to 1 by f. That means power is focus, power is equal to 1 by f. That means power is positive because 1 by f is positive for converging lens. And in mirrors what happen? In mirror, concave lens is converging. Concave lens is what? Converging, but its focal length is negative. That's why we add a negative sign other else here also. Again it will become what? 1 by f. F will become negative for converging mirror, and this negative is going to be cancelled out. Again for converging, it will net power will be coming as positive. So this is the way I will say that how you can remember the things. Okay. Now combination of lens. Well, let's suppose a lot of combination are coming, 2-3 things are coming at a single place, and now what you have to do? Simple. If 2-3 lenses are combined also, there is no need to worry. It is also a simple question. What will be saying at the place of writing all these number of mirror, which you simply will be writing 1 by f equivalent is equals to 1 by f1 plus 1 by f2, and if n number of focal lengths will be there, just keep adding them 1 by f3, 1 by f4, 1 by f5 till 1 by fn. Clear? And simply same way you can write what is 1 by f equivalent. You can write it as p equivalent, because 1 by f is equals to power. 1 by f1 can be written as p1, 1 by f2 can be written as p2, and same way it will keep on adding up. Correct? Correct, boss? See, here it is a combination of 3 I will say lenses are there. Tell me what will be the equivalent focal length. Just you have to calculate what will the equivalent focal length. Should we begin? A good question, because focal lengths are not given, only radius of curvatures are given. मतलब थोड़ा लंबा तो calculation होगा. Let's see how much we can do. Let's calculate for the first one. Surrounding is air. Okay. The refractive indexes are given to you. Firstly, write what is 1 by f1. 1 by f1, what you will say? Formula याद है ना? n by n of length divided by n of surrounding minus 1 divided by 1 into 1 by r1 minus 1 by r2. n of length is what? 3 by 2 divided by 1. लिखने का कोई फायदा नहीं है. Minus 1 by r1. Now tell me, this is the surface 1. Surface 1. The center of curvature is lying on the right side. And how much? All these are given as 20. So easy हो जाएगा हमारे लिए. This will become 20 minus. Second one I am going to take, again it is also 20 radius of curvature, but the center is going to lie in the left side, and conventionally I write it as negative. That means यहाँ से क्या मिलेगा मुझे? 1 by 2 multiplied by, here what I will be getting? 1 by 10. That means focal length f1 I will be writing as 20 centimeter. Focal length f1 I will be writing as 20 centimeter. Correct है ना? It will become 2 by 20. Correct. Now let's calculate what is f2 is coming. Let's calculate for f2. 1 by f2, how I will be writing? See, it will be n of length is equal to 4 by 3 minus 1 by r1. R1 again it is taken as negative, because now it will behave like surface 1. It will again negative minus of second one. This one is taken as positive. It will become positive. Correct. Now again put the value. What you will be saying here? It will become 1 by 3 multiplied by minus 2 by 20. That means minus 1 by 10. Answer for f2 will be coming equals to minus of 30 centimeter. f2 is coming equals to minus of 30 centimeter. Now let's calculate the third one. Let's calculate the third one. 1 by f3. 1 by f3 is equals to, again you will be calculating the same way. Can you say it will be having the same answer? f3 will be, because 3 by 2 is also there, minus 1 in bracket 1 by 20. That is the first one. Then again you will be taking second one as negative. That means f3 is also going to come as 20 centimeter. Correct. Now I have to calculate the equivalent. So if I am calculating equivalent, what I will be writing? 1 by f equivalent is equal to 1 by f1 plus 1 by f2, like this way. So what is 1 by f1? 1 by 20 plus 1 by 20. Then what is f2? Minus of 1 by 30. Correct. Now let's calculate how much it is going to come. It will be net. It will become 1 by 2 by 20. That means 1 by 10 minus of 1 by 30. Here it will become 2 by 30. Net f equivalent. Finally answer that you will be quoting is equal to 15 centimeter. अरे आया नहीं आया. Simple. बस calculation ही तो था. Anything else? Simply I have taken the sign conventions properly. A complete game is about sign conventions. Once you understand you had the confidence on sign conventions. I have told you in the first lecture only, the competition is about sign conventions in ray optics for majority of the competitive problems apart J advanced. Okay. So simple question. Calculation was good. क्या हो जाता है यार इसको? Okay, receiver नहीं है. Now see, next concept is about silvering of lens. Here we have taken a solid sphere. From solid sphere we were making lens, but what we have did, now we have painted out the outer surface. We have painted out the outer surface. Due to that, what will happen? One side will become polished. One side will become polished. I will tell you. It will become lens. Firstly, cut it and it will become lens. It is a kind of lens. It will become. And this is the complete cross section that is written here. It is looking like a plano-convex lens. Plano-convex lens. But what is happening? Outer surface is what? Silvered. Silvered means what? Nothing but polishing. You have polished the outer surface. That means, can I say this is the silvered surface? Correct. So it is net behaving like a combination of a lens and a mirror. If I have to draw the diagram, I will be drawing like this. I will have a lens and I have a outer surface that is behaving like a concave mirror. That means it will become a combination of convex lens plus a concave mirror. Okay, this is what the concept of silvering of lens. Whenever you silver any lens, you will have a combination of a lens and a mirror. Okay, so now if this is the combination coming, what is the formula for equivalent focus length? What is the formula for equivalent focal length? It is equals to, here it is given, 1 by f of mirror minus 2 by f of lens. 1 by f equivalent, here it is, you can see it will become equivalent mirror. Finally it is going to be behaving like a mirror. The formula is 1 by f of mirror minus of 2 by f of length. If it is coming negative, it will behave like a concave mirror. If it is coming positive, it is going to behave like a convex mirror. If it is coming infinite, then it is going to behave like a plane mirror. It is going to behave like a plane mirror. So basic things are represented here, and the same way you can define for equivalent power also, just it will become reverse. So that's why it is defined for power. So let's apply this in a question and try to find out the answer. Let's apply this in a question. See, what is the question is here. There is a plano-convex lens of radius of curvature 10 centimeter. Radius of curvature is 10 centimeter. Plano-convex lens is there, and refractive index is 3/2. Refractive index is silvered from the plane side as shown. From the plane side, it is silvered. Find the equivalent focal length. This side is silvered. That means, can you say it is nothing but behaving like a plano-convex lens and a plane mirror? This is the combination of these two things, and I know the focal length for both these things. What I will be doing? Firstly, I have to calculate, because this equivalent, this radius of curvature is given as 10. That means this length is given as 10. And what is the refractive index? Refractive index दिया हुआ है. This refractive index is given as 3/2. चलो पहले equivalent focal length calculate कर लेते हैं of the length. I will be saying what is n of length? 3/2 surrounding तो area minus 1 by f of r1. R1 how much you will be saying? It is nothing but 10 minus r2. When you will be writing, r2 is a infinite, that means it will be going tending to 1 by infinite. 1 by infinite always tends to 0. That means what will be left here? It will be 3/2 minus 2, 1/2, and here it is 10. That means focal length of the lens will be equals to 20 centimeter. It will be equals to 20 centimeter. Correct. Now what about the mirror? And if I will be writing the f equivalent, how I will be writing? 1 by f equivalent is equals to 1 by f of mirror minus 2 times of f of length. Now what will be saying? F of mirror, focal length of mirror, plane mirror. That means, can I say it is nothing but infinite, that means tending to 0, minus 2 times of f of length. F of length is equals to 20. Final answer will be coming minus of 1 by 10. That means f equivalent is equals to minus of 10 centimeter. F equivalent is equals to how much? Minus of 10 centimeter. अरे आया नहीं आया? Clear? easy peasy. एक और कर लो बस, that's it, so that you can understand. A very good question is there. मैंने आपके लिए संभाल कर रखा है. this one solve करो. See, पहले तो properly read the question and what are the given values. Water is placed in a concavo-convex lens having spherical surface of radii of curvature 30 and 60 centimeter. This upper side is 60 and downward side is 30. Okay. Surface of the lens is silvered as shown. Find the equivalent focal length of the system. You have to calculate what is the equivalent focal length of the system. What is the equivalent focal? पहले तो ये check करो कि what it is going to behave like. What it is going to behave like. कहाँ गया? हाँ, correct. See, one of the surface of the lens is silvered. That means this surface that is present here, it is what? Silvered. It is what? Silvered. So कैसे solve करेंगे? Basically at the end I have to apply that 1 by f equivalent जो होगा, that is, and you have to calculate the equivalent focal length. It will be equals to 1 by f of mirror minus 2 by f of length. This is what I am going to understand. And how many mirrors are there? पहले तो ये तो clear हो गया कि this is one. First thing is clear. If this is silver, I will be having one concave lens. Concave mirror. This is sure. Now, second one, what is here you are having? I will say here you are having again a lens, and what kind of lens you are having? Convex lens, type of convex lens, because it is thicker from the middle and it is thinner from the edges. Next one, what you are having, third kind of thing that you are having is this one, the water that you have. It is also going to behave like a lens, na? So it will be behaving like plano convex lens. Now what you will be doing, firstly you will be calculating For the first one, let's calculate for the plano convex lens. This is this kind of lens that you are having. N is already given. How will be calculating? 1 by f is equals to n of lens. How will be saying 4 by 3 minus 1 by r1. ये solve तुम खुद कर लेना. I am just writing, keeping the values. Here you will be saying what? 1 by, what is this surface? 60. 1 by 60 minus 1 by infinite, because this surface is what? This is what? 60, and this is what? Infinite. Correct? Solve कर लेना. You will get one answer. For first lens. For second lens, what kind of lens I am having? I am having some this kind of lens. One edge is 30 and one radius is 60. Again, apply the same formula. What is the n value is there? 1.5 minus 1 into 1 by 30 minus of 1 by 60. Correct? 1 by 30 minus 1 by 60, because both the things are positive. I am conventionally taking this direction as positive and downward direction as negative. Both the centers are lying on the upside direction. Correct? Now, when you will get it, third one, you already know if the radius of curvature is given as 30 centimeter, what is the focal length? Just half it, and it will be negative. Now put all these values in here, and how will be calculating the f of lens there also, because it is not a single lens now, it is two combination of two lens. If it is combination of two lens, what will be saying? 1 by f1 plus 1 by f2, because this is the formula for combination of lens. So it was a very good question where you had the combination of lens also, you had the combination of mirror also. Correct? So this will clear all the concepts. इसको solve करके values put करना, you will be having the answer. See here also same thing. You will be having 180 from here. Here you will be having 120. After that, just put the value minus of 1 by 15, because it is a concave mirror. Here we will be putting the values minus of 2 times of 1 by f1 plus 1 by f2. Exactly, that is what I have told you. Finally, after solving the answer, you will be having the answer as minus of 180 by 70. Minus of 180 by 70. Clear? So this was all about your optics portion. Finally, it is got completed. Now optical instrument part is there, that you can study from your reference book. Okay, this was the huge topic, and I hope that you have enjoyed this, you have understood this. I will again tell you, if you want to master this topic, you have to master about sign conventions. And the next topic is now the next portion of optics, that is wave optics. Now we are going to understand about wave optics. That will be starting from the next class. Until next time, keep learning, keep growing with Tapasya.